Okay, good afternoon, class. So today we're looking at exercise. Please settle down. We're looking at exercise 9.6. And exercise 9.6 is on page 308. Exercise. No, you gave me 306 last time. Please make sure. So why didn't you correct me? The first time is on 308. Huh?
Yeah, the first time is on 308. And then from 5 is on.
But it's fine. So we're going to do numbers 5 too? Okay. So let's look at number 5. So here we are told two circles touches at A. Then we are told that SAR is a common tangent to the circles at A. Okay, which means common tangent is in the circle is a tangent to both circles. Okay. The question says we must prove that if DE is parallel to BC. So the question we ask ourselves, if these lines were parallel, then what? Corresponding angles would have been equal. So that angle would have been equal to that angle, or the same is equal to that angle, which is down there. There's no alternate angles, or you could say the co-interior angles are supplementary. However, we know, so to prove that these lines are parallel, we're going to prove these angles are equal. But we know that A3 is equal to D1. Why? Tangential theorem. And A3 is also equal to angle BY? Tangential theorem. So there we already proved. Okay. So where do we start? We say that angle A3 equal. This is actually easy sum, so I didn't need to bring my x into it. Okay. But okay, since you insist. So if I need A3 equal to x, then what? D1 is also equal to x. Why? Tangential theorem. Okay. Then we know that A3 is also equal to angle B. So angle B is also equal to xy? Tangential theorem. So what do we say? State the obvious, yes? We say since angle B is equal to angle D1, which is equal to x, therefore DE is parallel to BC, or BC is. Please just don't die here. Okay? Otherwise I was write for a long report and what your last words was, and please, I don't have time for that. Okay? Alright? So these lines are parallel, why? The corresponding angles are equal. Okay. So drink a little water, Michael. You sure? Okay. You all okay with that? Let's look at number 6. In number 6 we are told that given CAE and CBF are tangents. People, if these two are tangents, what do we know? Tangent from common point, those lines are equal, so therefore those angles are equal. Not so? Then we are told that angle DA, or line DA, is equal to BD. So if these lines are equal, what do we know? A2 is equal to B2. Why? Angles opposite equal sides. Then A3 is 64. Calculate the size of angle D. Angle D is equal to 64. Why? Tan cos theta. Okay, so D is 64. Tan cos theorem. Okay. Angle C? Nope. We're first going to say that these lines are equal, not so. So we're going to say that AC is equal to BCY, tangent from common point. Which means to say that B3 is also 64 degrees. Why? Angles opposite equal sides. So 64. So to work out angle C, sum in triangles. Not so. There's 180 minus.
Leon Pfister,
2
can you
times
please
64.
report to the office? Leon Pfister,
Sum of triangles, and this
please
triangle A, C, B. A, C, B. I don't have to say that part. So angle C works out to be, that's 128. So it's 52. So check if 52 is correct. Huh? Yes, okay. There's 52 degrees. Then they want you to work out B2. But we know that B2 is the same as angle B2 is the same as A2. Why? Angles opposite equal sides. Okay? So then twice B2 plus 64 is equal to 180. Why? Sum of triangles in this triangle DAB. So B2 is equal to 180 minus 64 divided by 2. (180 minus 64 divided by 2 gives us 58 degrees. Is that correct? So that is 58 degrees and this one's 58 degrees. I'm going to calculate B1. Angles on a straight line. You see the importance of filling in your information on the diagram sheet. Okay. So we say that B1 is equal to 180 minus 58 minus 64. Which is, sorry? 72. 78 degrees. And these are angles on a straight line. Any confusion there? Easy, no? Sorry? 58. Now give me 78. But people, we should have known from the beginning it's 58. Why? The angle theorem. Not so? People number 7. In number 7 we are given that AB is equal to BC. People, if these lines are equal, what do we know? Angle A1 is equal to angle BC. Not so. Why? Angles opposite equal sides. Then the question says prove that AB is a tangent. AB is a tangent to the circle through at A, passing through AED. So we must prove this is a tangent to the circle. People, if that was a tangent, if this was a tangent to the circle, what do we know? We know that A1 would have been equal to angle D. Why? Tan cos theorem. Now in order to prove that AB is a tangent to the circle through AED at A, we're going to prove now that this angle is equal to this angle. Can you see that, people? But we know that A1 is equal to angle C. Angles opposite equal sides. But angle C is equal to angle D. Why? Angles are the same signal. So therefore, A1 has to be equal to D. Easy. No? I know you guys are asking yourself, come on, bring something more challenging. No? You're asking yourselves that question already, Zosie? Not yet. Alright, so where do we start? We say let angle C or angle A1 equal. So which other angle is equal to X? Angle C. So angle C is equal to XY. Angles opposite equal sides. And then angle D is equal to XY. Angle in same segment. And it's coming from arc AB. Not so? So what do we say now? State the obvious. Since what? Angle D. Why angle C? What, Mickey Mouse, are you talking? Since angle A1 is equal to angle D, which is equal to X. Therefore, now we answer the question. AB is a tangent to a circle AED. Why? Because angle between line and chord equal angle in the alternate segment. Or you could have simply write converse of the tan chord theorem. Easy enough? 4 marks or something like this. That's only if you want it. No? And most of us don't want it. It's because we're not going to study. No? Alright. People, given that HF and HE are tangents to the circle at O, at F and E respectively. Okay, so if HF and HE's tangents, what can be said from here? If these lines are tangents, what do we know? We know that HF is equal to HE. Why? Angle, tangents from common point H. Can you see that? So if those two lengths are equal, what do we know? We know that those angles are also equal. Angles opposite equal sides. Then we are told that angle C is 53 degrees and angle O1 is 106 degrees. People, if this is the center and that's a point, what is this? Radius. And the radius is perpendicular to tangent. Radius perpendicular to tangent. Can you see that, people? Show by calculation that HEDC is a cyclic chord. How do we prove cyclic chords? 1 of 3. First, exterior angle is equal to the interior opposite. Not so? Exterior angle is equal. So if we can prove this is 53, we've done the job. Not so? Secondly, opposite angle is supplementary. This says. Not so? Or the bow tie. No? Well, you guys call it the butterfly, whatever. The bow tie, yes. But there's no diagonals here. Are you okay? Right, so if we can prove that E2 is 53, we've done the job. Not so? Right, so of course, we won't go straight into that story. Not so? What can we say first? We can work out E1. Not so? We know that? Firstly, those lengths are equal. So OF is equal to OE. Why? Radian. Now, angle F1 is equal to E1. Why? Sorry? Angles opposite equal sides. Or you could have just written E1 is equal to F1, angles opposite equal sign, and radius, or radius. Then I didn't need to write that. Okay. Now what? We're going to be interested in E1. So angle E1 plus F1, which is also E1. That's why I said 2E1 plus 106 is equal to 180. Why? Sum of triangles. And it's triangle FOE. Follow. No? So angle E1 is equal to 180 minus 106, which is 74 divided by 2, 37. Okay, so that is 37 degrees, and that's also 37 degrees, if needed. I don't need. But which angle are we interested in? E2. We say, hang on. That's 90, not so? So we say E2 is equal to 90 minus 37. Why? Yes, the radius perpendicular to tangent. If you, that kind of girl, want to say the tangent is perpendicular to the radius, so be it. Okay. Lo and behold, 90 minus that angle is 53. So hang on. This one is equal to that. Okay. So now what do we say? Since, yes, since angle E2 is equal to angle C, which is equal to 53 degrees. Therefore, HEDC is a cyclic quad. Why? Converse of exterior, or you can just say exterior angle of a quad equals the interior opposite. Can I say cyclic here? If we had said exterior angle of cyclic quad, then we are already assuming it's a cyclic quad, not based on it. You see? So you're going to say converse of exterior angle of cyclic quad or exterior angle of quad equal the interior opposite. Yes, my girl. Yes. I thought you were going to ask me something mathematical. Right, verstaan julle? Right. Sound like you guys are going to have a good exam tomorrow. When you're writing? Tomorrow. Are you serious? Yes. Yeah. They didn't even give us time to study really. But you guys are reading. Right. Last one of it. We are given AQ is a tangent to the circle at Q. AQ is a... People, if this is a tangent to the circle, what do we know? Q1 is equal to P. Why? Tan theorem. Not so. Then, chord QP is parallel to AR. So hang on. Alternate angles are equal. Oh, now what? Without reading further, please don't ask us to prove that that is a tangent, because we can already see it's a tangent. Not so. Let's carry on reading. Prove that RA is a tangent. Come on. They don't even have us in suspense. Shame, she says. Alright, people, you see how easy it is. I'm getting upset, it's so easy. No? And you guys must feel the same. So where do we start? Sorry? We let Anya say what? Q1 equal? X. Alright. What did you say, Anya? Say, don't be shy. Almost Ramadan. Keep it clean. Right, Q1 is X. Which are the angles X? P. So angle P is equal to XY. Angle here. And then A2 is equal to x. Why? Alternate angles. With QP, not angle QP, QP parallel to AR. So hang on. Since A2 is equal to Q1, which is equal to x. Since that is the case, we answer the question. Therefore, RA is a tangent to circle through ABQ. Why? The reason? Angle between line and chord equals angle in the alternate segment, or converse of tan chord theorem. People, easier than this you can't get it. Okay. So that brings us to the end of exercise 9.6 on page 308, numbers 5 to 9.